Hi students, and here's Professor Schaefer to answer a question on problem 6.26. The question in particular is, how do you do these kind of problems? And so here is, again, a methodology of going through these problems like I did in problem 6.24. So let's take a quick look at problem 6.26. And here are some of the facts as given in the problem. The first fact is this one. It's telling you that mu is 1000 and that mu, which is the mean, and it's telling you that the standard deviation is 100. Now I need to give those values to you. If I don't give those to you, you can't do any of the problems that we're going to do. So problem 6.26 is one step more difficult than problem 6.24 because before you can look anything up, for example, one of the things you might be asked to do is to find the probability that the mean, that the sample mean is going to be between 890 points, whatever it is that we're talking about, and 1150. Knowing that the mean is 1000, that the standard deviation is 100, requires us to convert these two numbers, this 890 and this 1150, to a z-score. So here is the important formula that you need to know. We are going to take this x value, which is provided for us in this probability question, 890, and from it we'll always subtract whatever the population mean is. They gave that to us. That's 1000. We'll get an answer to that subtraction and then divide it all by the standard deviation as called for in the formula. The standard deviation is 100. And we're going to do this calculation twice. Once when we let x equal 890, and another time when we let x equal the other boundary of 1150. Okay, so let me show you what I've done on the rest of this sheet here to show you how you should do this at home. What I've done here is use this formula, use this x value, this mean and this standard deviation, and get a z-score. Okay, not an x value, a z-score. So here's my 890 that I started off with. Here it is in the formula. Here's my other x value of 1150 substituted into the formula, and I'm going to work those numbers out. When I do that, here's what I get. I have a z-score now of negative 1.1. How did I get that? Well, if I do this subtraction, I get negative 110 divided by 100. Use your calculator. You'll find the answer is negative 1.1. Same thing here. I take the z-score of this x value of 1150 and from it subtract 1000. I get 150. Divide that by 100. My answer is 1.5. Okay. This is about where I'm going to end, and you can do the rest, take it the rest of the way. And the reason why I say that is because now that you've recalibrated or restructured these x boundaries to z boundaries, all you're going to do is look up this boundary, this as z-score, on the tables that we talked about in the last problem, and look this one up, the 1.5, subtract them from each other, and out comes your answer in terms of probability. Now I hope that helped you. Some of the other problems you'll see in problem 6.26 are problems that say something like this. Let me just jot this down here. The probability that, find the probability that x is less than, let me use the less than symbol, less than 1560. If I were to ask you a problem like that, you would go directly to the z-score. You would go directly to this formula. Instead of using x of 890, I'd use 1560, and I'd take 1560 minus 1000 to get 560, divided by 100, which would give you 5.6. You want to know what is the probability that x is less than 5.6. I can tell you right off the top of my head, I know what that answer is. That's pretty much 100% because that's way above what the tables show. The tables only go to 3.0 pretty much, or 4.0 if you saw what I was using earlier. Okay, but it's immaterial really what this number is, so long as you know how to use that. So you're going to take this number, sub it into the z-score, and find that probability associated in the table. I would use the video for 6.24 to help you find where those other boundaries might be. And so here's the other kind of question I could ask. What is the probability that x is greater than 1200? Okay, if I asked you a question like that, you would do exactly the same thing. Put the 1200 in here, subtract 1000, divide by 100, you would get 2, and you would go to the z-score and find the probability of 2, take 1, subtract that particular probability from it, and there's your answer. Now, I covered the details on how to find these probabilities from the z-table in the previous exercise, so I'm not spending a lot of time on that now. I hope that helps you, and again, we'll see you tomorrow. Good luck.